Welcome to Lesson 2.1 Data Classification for AI Pipelines. This lesson explores how to assign sensitivity levels to AI data, ensure classifications travel through the machine learning pipeline, and align each tier with proper protection controls. By the end of this lesson, you'll be able to define classification tiers for AI data assets, explain label propagation across machine learning lifecycle, map data sensitivity to controls and retention, and design tagging and metadata enforcement policies. So let's begin. Classification tiers. Classification starts with defining tiers that reflect data sensitivity and regulatory exposure. Public data can be freely shared, while confidential data is intended for internal use and may contain business insights. Restricted data includes personal identifiers, health records, or proprietary algorithms, requiring strict access control and encryption. Each organization tailors these tiers to its risk appetite, but the principle remains universal. The higher their sensitivity, the tighter the safeguards. Classification tiers serve as the policy backbone, driving downstream decisions in access, storage, transmission, and retention throughout the AI lifecycle. Label propagation in AI pipelines. AI systems continuously transform and replicate data, from ingestion to feature extraction, training, and deployment. Each stage risks losing the original classification label. For instance, a sanitized dataset derived from restricted data might still carry residual risk if improperly labeled. Label propagation ensures that sensitivity levels persist across all pipeline stages. Integrating classification into ETL and MLOps workflows through automation or metadata APIs guarantees that security controls such as encryption or anonymization remain consistent. Without proper label propagation, organizations risk shadow exposure and non-compliance during audits. Mapping classification to controls. Effective classification isn't just labeling, it's operationalizing protection. Each classification tier must map to specific security controls. Public data might require basic integrity checks, while restricted data mandates AES 256 encryption, centralized key management, and zero trust access policies. Administrative controls, such as data handling procedures and mandatory training, com- complement these measures. Retention schedules should reflect both compliance obligations and model reproducibility needs. Mapping classification to frameworks like ISO 27001 and NIST 800-53 ensures global consistency. In AI governance, this mapping bridges the gap between policy intent and real-world enforcement. Metadata and tagging policies. Metadata is the glue that keeps classification actionable. Tagging policies ensures each dataset, model, and artifact carries a machine-readable label that defines its classification tier, owner, and applicable controls. These tags should live in data catalogs and flow automatically through MLOps systems using APIs. For example, a feature file tagged as restricted triggers encryption and redaction before deployment. Modern tools like MLflow or DVC can embed tags within model versions for traceability. Beyond compliance, metadata tagging provides discoverability, audit readiness, and a shared language across teams, ensuring classification integrity across the AI supply chain. And now for the key takeaways from this lesson. Classification tiers drive consistent AI data governance. Label propagation ensures end-to-end protection. Controls must align with tiered sensitivity. And finally, metadata tagging enforces visibility and accountability.